I'm going to give you some problem-solving guidelines that help you hopefully do well when it comes to solving problems. A lot of times you're going to look at a problem and might not know where to start, so what I'm going to do is help you kind of pull the problem apart so that you can at least have a process in solving these. Even if you don't end up getting a problem correct, if you follow a lot of what I have listed on the next few slides, you should at least be able to get partial credit. And this is just also good problem solving skills to have. So let's just get started. The very first thing you want to do is draw a diagram. I am a terrible artist. All you need to do is show some kind of picture of what's going on. The diagram is going to be really important in problems where things are moving, especially when you're looking at directions. So you will see, especially when I start doing examples on the boards and here, that my diagrams are terrible, but they still get the point across of what's going on in the problem. So almost every problem, and there will be a few exceptions throughout the year where we don't need a picture, but almost every problem you're going to want to draw a diagram. The second thing you want to do is list something I like to call the give and find. What that means is you read the problem, you look for what's given and what you have to find. Anything given is going to be the number with the units in the problem, and usually what you're looking for is what's at the end for the question. Third thing you're going to do is list any relevant equations. And the best way to figure out what equations you're going to need is to look at the give and find. So a lot of times someone will tell me, I don't know where to start. How do I know what equation to use? I'm going to ask first, did you write your give and find? So the give and find is really going to be able to allow you to look at the letters. And I don't like using that term, but really you're looking at the variables. So what variables are you given? What variables do you need to find? And then go look at your equation sheet and see which equation has all of that in there. The fourth thing you're going to do, and everyone always fights me on this, is to isolate the variable you are solving for. What that means. Unlike some other classes, so I think you do this in math, you might have an equation, you might plug in numbers and then solve with the equation as is. What we're going to be doing in physics is the math before we put any kind of numbers in. So what you're going to want to do is get whatever you're solving for over to one side of the equation all by itself, and then everything else will be on the other side. This is always the biggest hurdle, especially for those of you that like numbers, because I always do this without numbers. So after you know what equation you're going to use from number 3, you're going to manipulate that equation in number 4, isolating the variable. Number 5, after you have the variable isolated, you're going to insert the numbers and solve. I always keep units with my numbers, so anytime you see me solving, it is pretty heavy in the letters and numbers that you're going to be looking at, because you always want units with the numbers to make sure that you didn't make some kind of algebraic mistake. And especially when we get later on in the year and you do have more complicated equations, the units are going to help kind of be a check to see whether or not you did the equation correctly. And that actually leads right into number 6. Check that the units make sense. In other words, if I'm solving for position, I need to make sure that my units turn out to be in units of meters or kilometers or whatever. So if you get through everything, you check the units and they make no sense, that's usually a pretty good indicator that you made a mistake somewhere. Last thing you want to do is to check that the number makes sense. In other words, use your common sense and see if what you solved for makes any kind of physical sense. If you're solving for the speed of somebody who's running, know that people can't really run at 60 meters per second. So as you're solving, when you get to the end, if the number makes absolutely no sense, then you made a mistake somewhere. Numbers 5, 6, and 7 are a lot less important to me than numbers 1 through 4. So when you're going through these problems, if you solve and get a wrong answer, but you had everything else set up before you put the numbers in, you're going to get a lot more credit. If you tried to put numbers in early and didn't do steps 1 through 4, you're going to get a lot less credit because, like I said, I care a lot less about the numbers and any calculator errors you make than I do about getting the correct equation in the beginning. I'm going to show you one really basic example. There's really not much to it because we haven't gotten really into many equations, but I'll show you one basic example, and then when we get into more problem solving, you'll still use the same basic framework for when we solve those. Harry runs a distance of 6 kilometers at a constant rate of 3.7 meters per second, and the question is asking how long does this take? So the first thing we need to do is just draw a picture. This is such a simple problem that there's not much going on, but I'm just going to draw a picture. Here's Harry, and these little lines right here drawing behind him, these right here, I call those speed lines, and that just shows that he's moving. So usually if something's at rest, I write the word rest, and if something is moving, I show speed lines. So number 1, draw a diagram. Number 2, list the given and find. And this is what it always looks like. I literally write out the words given and find at the top. So what we know is that his distance is 6 kilometers. Symbol for distance is x. So x equals 6 kilometers. And it tells us his constant rate is 3.7 meters per second. Looking at the units, meters per second, I know that that's his speed. So v equals 3.7 meters per second. How long does this take? How long refers to time, so what I'm finding is my time t. Step 3 is to list any relevant equations with no numbers. The only equation we really know as of now, main equation, is that speed is equal to distance over time. We're dealing with distance instead of displacement just because there's nothing about direction in here. So speed is equal to distance over time. Step 4, we want to isolate the variable that we're solving for. What we're solving for right now is time. So I need to isolate the t by getting it all by itself, do some cross multiplying, and we know that t is equal to x over v. Once I have the t isolated, so this one little step right here, this is really what I care most about, that you can get to this point with no numbers, have what you're solving for isolated in terms of what you were given variable-wise. Now we're ready to put in our numbers. We know the value for x is 6 kilometers, and we know the value for v is 3.7 meters per second. However, I do have to be careful about the units. X is in kilometers, v is in meters per second, so I need to convert, and usually I go towards meters. So we know that 6 kilometers, there are 1,000 meters in a kilometer, is equal to 6,000 meters. So I can plug this in down here. T equals 6,000 meters over the speed 3.7 meters per second. 6,000 divided by 3.7 is going to equal 1,621.6, and it's going to keep on going. The units for that would be seconds. And before I put the unit in, I just want to show you how I know. Meters, so I'm looking right here, meters divided by meters per second. So meters over meters per second is the same thing as saying meters times seconds over meters. The meters cancel out, you're left with units of seconds. So my answers, units make sense. The number, it's going to take him 1621, so seconds, about a half hour. I think I'm doing really bad math right now. Maybe a little bit less or more to run 6 kilometers. That's okay. That makes a lot of sense. 5Ks can be run in about a half hour or less by fast people. So my number makes sense, my units make sense. And then my final answer, you don't want to put that whole run on decimal, and I'm not really overly concerned with sig figs. So just round to about 1 or 2 decimals depending on the problem. Use your judgment. So I'll say my time is about equal to 1621.6 seconds. A full credit problem, or I should rephrase, a full credit answer, if it's numerical, will have the number as well as the units. I do take off points if you forget the unit or you have a wrong unit, because the unit is important. But even if you get this number wrong, if you draw a picture, if you list the give and find, if you do this part, you're going to get the majority of the points. My focus is not on the calculation and whether or not you can put numbers into a calculator. My focus is in, can you do the physics part of this, and the math comes secondary.